Hey A-level physicists, what's the crack? So today we're going to do some circuits questions looking at what EMF is. So previously, you've always known that the voltage across the cell is always the voltage we've been using, but actually the cells aren't perfect, so they have a tiny amount of internal resistance. So you get questions like this, you always want to draw like a pretend cell around it so that you recognize that the voltage that comes out of that cell is not always what the EMF is. So the EMF is called the electromotive force, and if the cell was perfect, that's what the voltage it would give us. So the equation in your data sheets is always V equals EMF minus I times R. So R is your internal resistance, what makes that cell not perfect. So we can clearly see that V is always going to be lower than E because there'll be some energy lost due to the internal resistance in that cell. So I want to describe a procedure so I can figure out what this E is. So I know in physics we always want to plot graphs at the end of experiments. So the equation for a graph is Y equals mx plus c. Clearly I have a voltmeter and ammeter, so I'm going to be taking readings of my voltage and I'm going to be taking readings of my current in amps. So the graph that I'll end up plotting will have voltage in volts or potential difference in volts against current in amps. So I can clearly see I want my Y to be my V, but I want my X to be current. So I just want to change this equation to make it look like this form. So what I'm going to have is V equals minus IR plus E. So now I can clearly see that my X is my I. So I might just write that a bit easier for myself. So V equals minus R times I plus E. So I can clearly see that M is going to be my minus R. So the gradient of that line is minus R. So if I want them to find out what the internal resistance is, I just need to take them, find the gradient of this line. So whatever the gradient is, and I take the negative number of it. So R is going to be negative of that gradient. And remember, gradient is just the vertical divided by the horizontal. And then what it says here is that the EMF is clearly going to be our C, which is our y-intercept. So whatever the y-intercept is going to be equal to my EMF. So all I need to do now is tell them how to do this. So I'm just going to tell them that I want them to take readings of the potential difference from the voltmeter and the current from the ammeter and record that in their table. They're going to change the resistance using this piece of equipment, which is my variable resistor. It just does what it says. Variable means we can just change the resistance. Then we can get lots of different data points for voltage and current so that I can plot my graph. So that's grand.